So, hi everyone. A very good evening to one and all who have joined so far. Can someone comment in the YouTube comments box whether my voice is audible and are you able to see the PowerPoint deck? Okay. Okay. Thanks a lot. Yeah. So, I think we can give a start now. So let people would join parallelly. So, thanks everyone once again for joining today's event. And in today's session, we are going to cover about what is Snowflake with a deep dive session, and what is cloud data warehousing, and what is the crux of different data storage categories. There is database, there is data warehouse, there is data lake. So there are different data storing and the database categories are there. We are going to see what is the crux of each different categories. Okay, I'll go ahead with my slide deck. Yeah. So as a quick prerequisite, I expect there should be basic knowledge of SQL and to the level of what at least a database is. I guess most of you would have used at least one database for your use case. Even it could be a simple MySQL database for that could act as a backend for your application, and some familiarity with data like JSON or XML kind of thing. I mean the semi-structured data type data I'm talking about. So I just expect that kind of prerequisite. Even if it is not so, and if you are not following up with the slide deck, stop me anywhere. Okay, you can't stop anywhere, but you can post your comments asking about it, and whenever I could see the comments in the YouTube, I'll answer, try to answer that question. So as part of speakers, two of us are going to talk. One, myself, Dinesh Kumar Prabhakaran. I role play as product manager at a company called Kissflow. And similarly, we also have Prashant, who is a technical lead at Kissflow for the analytics squad. So this is going to be our agenda. First of all, I'll demystify what is the core architecture difference in database, data warehouse, and data lake. And then I'll give a glimpse about what is cloud data warehouse. And then we'll go through what is actually Snowflake is, and what are the key features that differentiates Snowflake from other cloud data warehouses. And following that, we'll be having a deep dive demo, injecting the Twitter data in a near real-time fashion into Snowflake database, Snowflake data warehouse using Snowpipe. And once the data is arrived, we'll also do near real-time analysis in Power BI by connecting that Snowflake data warehouse, Twitter data in Power BI. So, yeah, this is going to be our first thing. I think the current time is a bit of crazy and a slightly confusing time as well, because more and more companies are shifting towards data lake. Yet the traditional data warehouse and databases continue to provide value as it is for decades. Now, to add that, we also have increasing popular term like lake house and delta lake concepts as well. The concepts we both discuss here will be common that would fit for all the cloud providers, not just Azure data services as well. And looking at this, does both give the same feeling for you? When we go to a hotel, while we are ordering a tiffin like dosa, we'll be having a ton of options, right? But all of those dosa is going to have the same base material, that is that batter, right? On top of the batter, if nothing is put, then it becomes plain dosa. If something is added, then it becomes some a special dosa kind of thing, a cheese dosa or masala dosa, whatever it may be. Similarly, all the database variants that are present are going to do the same job. That is, it is going to store the data, and it is going to allow the developer or the other side people to fetch the data, right? The basic functionality is same, but like each dosa variety has a unique difference in each of them. Each database variety also have a unique functionality that solves a specific problem, right? So knowing that what each database type is solving what type of problem, and then taking decision would be a great help. And it helps in what to say in a many fashion. Whether growing the product itself would be tremendous, or you would be needing very less migration while you are doing any changes in that product, whatever it may be. But knowing the difference is very important. So let me start with the first one, database. As you see here, the main crux of a database is collocation of compute and storage, right? So storage, I think you know what I mean here. That is to store the data. Compute here, what I mean is whatever the query we submit to the database to fetch the data, that database should be using some compute to fetch the data, to do the aggregations and all those things that are present in the query and fetch the result, right? So in a database, the compute and storage will be in the same mission, right? Like you take an example of a simple laptop that you have. Your laptop is comprised of hard drive and the RAM space, right? So hard drive would be storing the data, and the RAM space would be used for the compute. This is what a database would be doing, right? So both are deciding in the same place. So when you are installing PostgreSQL kind of database, both the compute and the storage will be consumed, will be present in the same database. Sorry, in the same mission. Here, in case it is your laptop, right? So when it comes to database, the collocation of compute and storage will be together. That's the point I'm coming to say. And the second main point is schema on write. What it means is, if you want to store some data into a database, before that, first you need to execute the DDL statements, that is data definition languages, which is nothing but you need to create a table, and that while creating itself, you need to tell that so and so column name, that column name should be so and so data type, and all those kind of specifications. So you need to define a structure by creating a table, and then only you will be able to insert the data, right? So you need a schema before you start writing. That's what that main crux point is. You'll be able to understand while I talk about data warehouse and data lake as well, this particular point. And in my perspective, I'd be recommending database when you're having only the structured data. That too, it is less than a terabyte or so, right? You may see in the databases documentation like PostgreSQL or Microsoft SQL Server, the database size they would have mentioned would be very huge, but there are some constraints, and in most cases it would not be suitable. Okay, so for a quick kind of decision making, if you can simply mean like this: if your data is of less than 1 TB, that is from now till 5 years or so time, then you can think about database, choosing a database. Similarly, if your purpose is going to be only for the OLT, that is online transaction processing, that is just to store the data and retrieve, the application data and retrieve. Only that purpose, then database is fine. I'll in the upcoming slide, I'll clearly define what OLTP and OLAP means. And when database is not recommended is if you are going to have an ad hoc analytics, right? Analytics is simply it's a very broader term. Simply, it is nothing but fetching the data, applying query, and what to say, getting some insights. What I mean here, ad hoc is your data will be stored in the database, and suddenly, suddenly an use case appears, and for that use case you need to fetch play a huge query on the database and fetch the result. That use case could be, let's take an example. There is a sales data. Suddenly the CEO would need an insight like, what is the last 5 years average of so and so products in the winter season that is being paid by credit card customers. So this is a very, the statement could be very simple, but it would be accessing multiple different tables, multiple different joins would be needed, multiple different aggregation columns would be involved. So preparing a query like this and directly hitting the database would incur a lot of compute power, right? You can also argue that we could create a cube on top of database and play over that. Again, for creating a cube, you are setting up a different layer, right? You're not going to hit the database directly. The database will be there, the cube will be sitting on top of it. On top of cube only, the queries are running, right? So ad hoc is nothing but you even don't know what kind of cube would be needed. So that's what I mean for ad hoc. Okay. Similarly, if your dependency would be arising in terms of sharding, then database would not be a right choice. Sharding is nothing but you will be splitting up the data with the specific chunks of portion, and you will be storing that in different databases separately. So such a kind of needs would be arising when the time grows, right? Not at the initial time, but when the time grows, like 2 years or 3 years, the product will be generating more data. At that time, you would be needing sharding. So considering all these factors, you can decide whether database is needed or not. Similarly, the storage models are widely available, from relational, graph, key value, document oriented, column oriented, as you see in the screen. So I broadly classify it into two structures. One is SQL and the other one is NoSQL, right? SQL is nothing but relational. You will be having the plain rows and columns kind of structure. So that is nothing but the relational kind of database storing model, and all other things, graph, key value, document oriented, column oriented, are NoSQL kind of thing. So I'm not going to dive very deep into this particular concept, because that would that would deviate from today's topic. But I'll just tell one concept alone. If most of the data that is being stored and being played for analytics will be in the relational type only, right? All the other types will be very lesser, right? So you can just mean till to that point. And if you take about document-oriented databases, it is nothing but the MongoDB. MongoDB is one example for the document-oriented databases that would be storing the data in JSON format, right? So we are going to we are going to consume the data in JSON format and store the data into the same JSON format itself into the Snowflake, and we are going to query on top of that. So we are going to fetch the data in JSON format, and we are going to play with Power BI in relational format, right? That's what in today's demo it's going to be. While we come to the demo, it will be more clear. Next, let me talk about data warehouse. It's nothing but the compute and storage will be separated. While in the database, it was nothing but the compute and storage was combined together in a single machine. Whereas when it comes to data warehouse, the compute and the storage will be clearly separated. So when your storage needs increased, That is, when your data size is getting increased drastically, then you can scale the storage part alone. Similarly, when the data size is not growing that much, but your compute is being consumed so much, that is, the number of requests are be received is so much means, then you can scale compute alone. As you see in the diagram, we could store the data in a separate storage layer, and the compute can be in a separate layer. So likewise, when the compute need arises more, we can add another compute node. Similarly, when the storage need arises more, we can simply add the data to the blob storage. So there will be no direct computation on this. This would save a lot of price in terms of when you want to increase the compute or decrease the compute separately without depending or without disturbing the storage. And like database, a data warehouse also has the same analogy, that is schema on write. You need to have have a table created in the data warehouse before you start to inserting, right? So you need to have the schema before you start, right? That's the main point. And when I would recommend data warehouses, if you are very sure about metadata, that is what kind of data or what is the schema type of the data is going to be stored, then definitely we can consider data warehouse. And another thing is, even though the data size is a little bit more, let's say it's 2 TB or 3 TB or 4 TB, but you are sure that ML or AI are not needed much at this point of time or immediate or in a immediate near future, then you can definitely choose data warehouse. And also, when you are sure that you are not going to query over a large data set, right? Large data set, I mean here is terabytes of data, right? When you're sure that you are not going to query very large size of data sets, then the choice would be fine. And one more very important scenario to choose data warehouse is, if you have a scenario where you need to expose your data out, right? Not just a product is going to consume the data warehouse, but also the external consumers would be needed to access the data warehouse, and they might wish to connect with their own BI tools like Power BI or Tableau, or they might need to analyze it in their data science tool, some data science tool like Data IQ or something it may be. But you need to expose the data to customers safely and securely, then definitely data warehouse is a best choice, I would mean. And when data warehouse is not recommended is, obviously when you are having your having unstructured data that need to be stored and analyzed like image and video, data warehouse is not recommended. Similarly, when you have semi-structured data with multiple levels, what I say here is 5 or 6 to 10 or 15 kind of levels. In a JSON file, if you have 1 or 2 levels, then it is fine. You can somehow manage with data warehouse. But when it goes beyond 6 level or 10 level, then the data warehouse, it's not recommended, I can say. Even if the data warehouse still can perform, but it's not recommended. So when it comes to data lake, it's again, what to say? Yeah, it's again the same analogy, separation of compute and data. But the schema, the schema on read makes the difference between database, data warehouse, and the data lake. Here, you would be storing the data as it is, but while you are reading, you would be creating the schema. Okay, I'll explain it in the next image. So here, as you could see, you might have different formats of data that is being collected via an ETL tool, and you are storing it in a data lakes like Azure Data Lake. But you will not be defining any schema while you are inserting the data into a data lake, right? Only while you're analyzing it, start analyzing it, you will define the schema. For example, for the analyzing, you're having here a HD Insight cluster, or even you can think about some Spark cluster like Azure Databricks, or some other open source query engine like Presto, whatever it may be. So only whilst you're analyzing that, you will be creating a table in Spark cluster. You'll be creating a table in Apache Hive or Apache Presto, right? So only at that time you will be creating a table and you'll be start analyzing it. Once you start analyzing it, that particular data will be ready to be consumed by the next layers like analyzing, and you will be able to connect it with BI tools or even on Jupyter Python notebooks or whatever it may be. So that's how a data lake works. So the main difference in data lake is schema on read, not schema on write. I hope the question is clear. I mean, the concept is clear. So, by the way, when I would recommend data lake is when you have all types of data, that too, you're not sure about the data size as well. You have so many what to say, different types of data, and well, different types of data I mean here is image, or as a structure like RDBMS, or semi structure like JSON, or image files and all those things, right? So when you have different types of data, you could definitely choose data lake. Just a minute, guys. I just get a phone call. I'll quickly catch up. Okay, that was a small phone call. Just a minute. So coming back, where was I? Yeah. So, and one more thing is, you are pretty sure that you are going to query over large data sets means, then definitely the data storage layer should be the data lake, right? If you're going to query over 3 terabytes of data, and that analysis involves both the structured data analysis and image data analysis, then definitely data lake would be the right choice. And another main use case is when you have a system like, or when you have a thought process like, okay, I am going to store the data as of now, but I'll not do any analysis right now, but I'll do whatever analytics needed later on. For example, if you can take any application like Uber or Swiggy, whichever B2C product, they would be gathering so much of data, right? Let's take about Uber. They'll be gathering data about what the user is, what kind of car a user has chosen, what is the route he has traveled, and what kind of payment information, what in what mode the payment has been given, what is the comments that user has given, what is the cab driver doing, and what kind of cab that particular driver has picked, so that particular user. So like that, so many data they will be collecting, right? Both that includes both the behavior data, high level data, and the low level behavior data as well. So all these data they'll collect, but at one point of time, or in a frequently and a scheduled point of time, a data analyst or a data scientist would be playing with those huge data. He'll be combining with other data like weather information, or some government information, all those information, and he'll derive with some insights, right? So while for such kind of internal analytics use cases, data lake plays a major role, right? And when it is not recommended is, if you have a scenario like you need to store the data and that data should be readily available for analytics then and there, right? So in that particular case, I won't recommend data lake, right? Even you can do that. Once again, I'm telling you can do that, but I won't recommend that. That's what I'm coming to say. So now let me tell about OLTP and OLAP. OLTP is nothing but online transaction processing, and OLAP is nothing but online analytical processing. So there are two categories of databases, as I have mentioned here. Even in the previous image, you could see that. So all these things are OLTP: Azure SQL Database, Azure Database for MySQL, Azure Database for PostgreSQL. All these three we can cover it up as OLTP databases. But when it comes to Azure SQL Data Warehouse, which is nothing but Azure Synapse Analytics and Azure Data Lake Analytics, these two services specifically serve for OLAP purpose, that is OL, online analytical processing. So as a database guy or a data guy, we need to clearly know what in which category database kind we need to choose that particular database for a specific use case. Okay, so if you are going to when it comes to a OLAP database, then the data will be nothing but the historical data, right? Not very real time data. It will be almost, it will be historical data. And there will be more read because analysts will be playing more select queries. They'll be doing more reads than writes. The writes will be very lesser. The writes will happen in batches in specific interval times. But when it comes to OLTP, operational data will be there, that too in a row format. Whereas in OLAP, the data storage format will be in a column format. In OLTP, it will be in a row format. That is username, address, phone number, like that. Okay. In an OLTP, both the read and write will be happening simultaneously. Let's take an example of a simple application. Again, that Swiggy itself. While you're ordering, that particular order has to be updated in a subsequent time, and that particular order has to reach the specific food store in a very quick time, right? So the the write also should happen very quickly, and the read also should happen very quickly. So what Swiggy would be having is both OLTP there for such kind of operational data flows, and OLAP for the analytics data flows, the data requirements. Okay. And when it comes to query patterns, in general, OLAP will be fetching large number of records. Large number, which I mean here is even that could increase from 10,000 to lakhs and lakhs of records. Even that would be included with a lot of aggregation columns, and that particular select query would be having complex joins. There will be a lot of filters, drill downs, slice and dice. A lot of analytics queries would be included in that. But when it comes to OLTP, a specific set of small records only will be fetched. As you could see, while you are scrolling a particular for a food types availability, while you're scrolling and searching the hotel's availability, only 10 or 20 will be fetched at a second. While you are reaching 17th or 18th hotel, there will be another query fetched, and the next 20 records, next 20 hotels will be fetched, right? So that's what it will be happening in Swiggy while you're accessing that. So that is nothing but the operational data, right? So there won't be much heavy joins would not be there. It will be having simple joins. And while coming to the users, a OLAP database would be used mostly by the data analysts and the decision makers, while the OLTP databases will be used by the application builders and the backend developers who are taking care of that particular app, right? Who are building that app. So while coming to providers, as usual, for the OLAP, we have examples like Snowflake, BigQuery, Teradata Vantage. While it comes to OLTP, as I told earlier, it's nothing but SQL Server, MySQL, Postgres, or Azure SQL, Azure Cloud SQL, right? In a real scenario, as I told with the previous example, Swiggy, an application would be having a hybrid data architecture, right? Both for the OLTP, there will be some databases, one or more databases. For searching, there will be some databases like Elasticsearch or Apache Solar. And similarly, for the analytics, there will be some data warehouses like Snowflake, or even some big data architectures like HD Insight. There will be separate data warehouses, right? Sorry, data storage patterns. But while you are taking as an application as a whole, it's always going to be a hybrid data architecture, unless it is very small app. Now let's jump into Snowflake data platform. I'd call simply it as a data warehouse as a service, right? So when it comes to data warehouse, there are two categories are there. One is that is available, that can be configurable on premise, and the other set of data warehouses, it can be configurable in cloud. There are some data warehouses which can be configured both in the on premise and cloud, right? Let me give one or two example. When it comes to on premise data warehouse, you can take about the old versions of the initial time of times data warehouses like Teradata. You can it is a data warehouse, but you need to have a data center, and you need to install the Teradata into that you need to install the data warehouse, and you need to set up the data warehouse all by yourself. So you would be needing a DevOps guy, you would be needing an IT team, and to manage that data center, all those headache, it comes to that particular person who opts for on-premise data warehouse. Then the next generation came. That is, some part of data warehouse can be configured in the on-premise, and some part of data warehouse can be configured in the cloud. For the same purpose, Teradata came with a concept called Teradata Vantage. They just made it configurable to install in any cloud provider like AWS, Azure, or GCP, right? But the complexity was still continuing. Like still you would be needing an IT guy or a admin guy to take care of that particular data warehouse. And there comes the latest part, data warehouse as a service, that is fully cloud. You don't need to manage anything on your own, and you might not need a DevOps guy or an IT team to specifically dedicatedly manage that particular data warehouse environment, because it is fully available in cloud in any of the cloud providers based on our choice. One best example is Snowflake. I think that gives a clear idea about what I mean about database warehouse as a service. Yeah, cloud native is really a big gift, and that keeps on going. And you could see that benefit in this COVID era as well. The whole the software the whole software business is living all because the major credit goes to this cloud native architecture, in my personal opinion. So as I told earlier, cloud data warehouse has we can view four, as I have listed, there are four key players. One is Azure Synapse Analytics, one is Snowflake, and one is Amazon Redshift, and the other one is Google BigQuery. For today's context, I'm going to talk about Snowflake, right? There are specific advantages and disadvantages in each of those, but comparing all these four, if you have a very lean team, and you're not sure about what could be the data size or what could be the compute, you're not sure you're unable to plan about that futuristic things, like what's the compute I would need next year or next month, or so maybe in that case Snowflake would be the best choice in my opinion, right? So when it comes to Snowflake architecture, it is very simple. You can store all your data. It will be extremely simple, and it will fully support ACID transaction. That is, I hope you know about ACID: atomicity, consistency, isolation, and durability, right? It fully supports that ACID transaction capability with read consistency, and also it fully supports ANSI SQL. Like, if you are going to deploy Snowflake, then you need not learn another query language, right? All you need is SQL, ANSI SQL's knowledge is more than enough to query the data. Why I mean specifically mention here is, there are specific systems like Apache Pig, right? It is a big data software. If you want to use Apache Pig, then you need to learn Pig Latin. If you want to use Apache Hive, then you need to learn Hive QL language. Even though they are query language, SQL query languages, they widely differ from the actual ANSI SQL pattern. But when it comes to Snowflake, almost all it closely matches near 90 to 95% for the ANSI SQL's keywords and patterns of most famous databases like Microsoft SQL Server and PostgreSQL. And when it comes to architecture, it is very simple. So you would be having a centralized storage where you will be storing the data only once, and for loading, you again, you can use Snowflake itself, which Prashant would be diving in deep while he showcases. And loading, I mean here is ETL, right? From the source data, you need to bring the data and store into Snowflake, right? That's what I mean here, loading. And ad hoc analytics is nothing but either you have a plan or you don't have a plan. Definitely, you can play with the Snowflake data warehouse, and you can get the result in a very good performance. And by the way, Other scenarios like managing a database or data sharing, you would be able to share this data to even the external people like who doesn't belong to your company. You can do a lot more kind of things. So what makes Snowflake unique? I just mentioned five features alone, but there is a lot more. But considering the developer's point of view, if I am a developer and these 5 points would be helping me. So in that scenario, I have just mentioned this 5 points a lot. But if you dive deep into Snowflake, you'll be knowing a lot of other unique features as well. The first one is auto scaling. It is nothing but dynamically, Snowflake will be able to increase the compute by itself without our intervention. Okay. For example, Amazon, I think Flipkart's, let's take Flipkart's Big Billion Day. Definitely, they'll be increasing their compute power to a very huge extent. Okay. Before that particular day begins, they'll be increasing their compute power to a huge extent because they need to accept more logins, they need to do more processing, and at that time the application should not go down, right? What happens, just imagine a very rare example. What will happen if same amount of requests, let's say 90% increased number of requests happening in a very normal day? Definitely that application would go down, right? At that time a person would dive in, and he would be increasing that number of servers, and only then he'll be able to bring up that application back to a normal state again. But when it comes to Snowflake, that auto scaling will be very smooth, and that is not available, or I can, well, how I can say is that is not so easy in traditional data warehouses, definitely, right? And next concept is Snow Pipe. So it is in a very simple words, it is a serverless concept for data loading, right? If you, in a general scenario, you have a data warehouse to store the data, but to load the data, you would be needing like an ETL tool, or a dedicated IT team to inject the data into Snowflake, right? So using Snowpipe, you would be able to achieve a maximum portion of that needed features via the Snowpipe itself, right? All you need is just you need to set up the source data alone. The Snowpipe itself will automatically shoot up required virtual warehouses, do the specific fetching from the source data, do the required simple transformation, and it will inject the data into the Snowflake, right? You will see more in detail when it comes to demo. And zero copy cloning, I would definitely say it is a very beautiful feature in Snowflake, because as I told earlier, the data is going to sit here, and the data copy will be only one. But in a real product scenario, there will be different teams, right? Production team will be there, sorry, different environments. Production environment will be there, development environment will be there, and QA, that is nothing but testing environment, will be there, right? So in general, if three separate teams need to work on same data, then you need to copy that particular data into three different environment, right? So for example, if you are having 1 TB of data, then for production you should be having 1 TB separately. For the development, you would be having a separate copy, right? And that development team would be using that data, and similarly test or QA environment. So for 1 TB data, it's going to be 3 terabytes of data, right? So again, once again, the synchronizing between these three databases also a big problem. But when it comes to Snowflake, internally there will be only one copy of data. On top of that, you can create as many environments as you need, right? So all those teams will be accessing on the same data, but one team's change will not be visible to other teams, right? That's very like, what to say, very beautiful feature, I would say, in Snowflake. And one more thing, Schema on read, I have mentioned in my slide that data warehouse specific core architecture is schema on write, but Snowflake supports schema on read to some extent, I would say, right? Let's imagine that you have stored the JSON data as it is into Snowflake. Still, by creating a view on top of that, you would be able to query the same JSON data, and without copying that particular data into a separate flattened structure, you'll be able to query the data, right? This also you'll understand better while we are showing the demo. And time travel. So I think you know about versioning concept. If you are using databases like Elasticsearch, you would always backtrack to a previous version of that particular data. For example, let's consider that you have an application running with Snowflake as its data warehouse architecture, data warehouse in its data architecture, and something happens problematic, right? And you need to roll back. So in Snowflake, in a couple of by just running a couple of queries, you can quickly navigate back to yesterday's or last week's data. I think Snowflake is supporting till 90 days. You can even navigate back till 90 days of old data, and you can turn on the application back to life, right? So providing 1 or 2 days is very normal, but a longer period of time is a very challenging thing, right? But Snowflake does it. So I just listed these top 5 features alone. If you want, you can go back to Snowflake and website, and you can learn more. So for a diagrammatical purpose and to understand it better, I just let me just explain a couple of concepts again. So when it comes to auto scaling, I just told about instant, right? So just consider this dark line is what to say, traditional data warehouses, where you will be able to scale down and scale up, but not so legibly, right? Let's take an example that this blue line is your application's usage. When you guess that there is going to be a hype, you need to scale up the data warehouse immediately, and that sky hype would be appearing maybe 1 or 2 days or 1 or 2 weeks later even. But till then, that increased capacity you only need to pay. But when it comes to Snowflake, it will be so accurate that based on that application's usage, it will be so accurate to increase the compute power along with that application usage, right? You would be able to see this comparison when you have used data warehouse like Teradata, and when you switch to a data warehouse like Snowflake. You could see this example more clearly. So the analogy is very simple. Pay for what you use, the clouds analogy, right? That's what they have also achieved it. And as you could see in the diagram, the data sits at the center. Either it could be a flat CSV, flat table, or it could be semi-structured files like CSV, JSON, or XML, or even it could be big data formats like Parquet or Abro. Any kind of data that can sit in Snowflake as a single source of truth, and each team can access that same data, and they'll be able to play on top of that without getting disturbed, right? So for example, let's consider that marketing team would be accessing some high-level behavior data, that is website behavior data from Snowflake. So they would be needing very small warehouse, and in a very lesser time, they would complete their work and go on. At that time, they would be very small warehouse, and you can simply kill that. Similarly, when there is a team for a data science team, they would need a very large compute power. So you can dedicatedly create a large compute power for data science team alone, and they can play over the same data. Similarly, there could be a BI team, and they can have their own compute power, and they could play with their own tools like Tableau or anything it may be. So what I'm coming to say is, if a data science team is consuming all the resources, that will not at all affect marketing team or BI team, BI teams working. This team's working is totally isolated from data science teams working, right? So that kind of multi-cluster shared data architecture, the Snowflake is built upon. And as I told earlier, Snowflake will be comparatively very simple when you go compare it with other traditional data warehouses. So you might not even need any dedicated DevOps guy to deploy a data warehouse, to auto scale it, to bring it down, and all those things, right? You would be very much lesser dependency. I could say like that. In very rare cases like user management and all those things, a DevOps guy or a respective person who is following the company's protocols, that particular guys would be needed, but not for the actual data warehouse maintenance purpose, increasing the compute power or increasing the storage power and all those things. You would need that won't be a big burden. That's what I come to say. And as I told earlier, Snowflake will be able to support semi-structured data as well. So semi-structured data here, it means JSON or XML, which would be having multiple levels of data, or it could be structured for data where it will be clearly one level, that is rows and columns, or native data like Avro or Pacuvate, whatever it may be, Snowflake will be able to support. And when it comes to accessing Snowflake data by the raw developers, you have multiple options. Like either you could be using a ODBC driver, or you could be using a JDBC driver, or you could be using the web UI itself to directly query the data. Apart from this, you'd be able to access Snowflake data via specific programming languages as well. Python has a library, SQL, what is that? C# has that library. In Java, all the major programming languages have libraries to be queried upon the Snowflake, right? So before Prashant would start the demo, just have this in mind. The end goal of a data architecture should be very simple. The copying of data should be very lesser between different teams, right? And you should allow this user of the data user who is going to consume the data to make smart decisions quickly, right? And you need to choose a data stack based on customers' need, not that you know. Let's take that you know what to say. Okay, just take an example. You know PostgreSQL very well. For that particular purpose, you should not choose PostgreSQL, right? For the customer's need or the product's need, the PostgreSQL might not work. In that case, you should drop it out and you should pick a data lake or data warehouse, right? That particular goal you should be definitely having, right? So with that, my slide deck ends. And Prashant, are you there? Prashant? Okay. So while Prashant is joining, let me try to answer the questions. Just a minute. I'll go for a mute quickly. Okay. So Prashant would be joining in a couple of minutes. While he joins, let me address the questions here. So Delta Lake, thanks Hari for your comment. And Hari has asked, is Delta Lake and Data Lake is same? So both are widely different, right? Delta Lake is a concept. The way of storing data is nothing but a Delta Lake, but Data Lake is totally different. Under Data Lake, only the specific things are coming: Amazon S3 bucket, Azure Data Lake, or Google Cloud Storage. All these comes under the Data Lake, where you would be storing the data, right? You have 10 CSV files. You would be able to store the CSV files into Data Lake. Okay. When it comes to Delta Lake, it is nothing but you have stored the CSV file, but you would be converting that CSV files data, which is nothing but rows and columns of data, into a different format, which is nothing but Delta Lake format. And on top of the Delta Lake format, you will be playing queries. Delta Lake format has a specific advantages to query large amount of data in a short time, right? Like CSV is a format, Parquet is a format, Delta Lake is a format of data. In that format, you will be able to store, right? So both are totally different. And remaining questions I'll take after Prashant's demo. So we have Prashant here. Hi, Prashant.
Hi, Dinesh.
Yeah, I think what is
You guys can
happening?
hear me?
Uh,
Yeah, let
uh,
me
I
share. Yeah.
you can
I'm
you can minimize this StreamYard window. You could share a screen with
yeah,
what
yeah,
you're
yeah,
going to share.
sure. So, so hi guys, this is Prashant here. I'm working as an lead engineer in Kislo. Okay, so let's get into what we are trying to do. Right. So we have the tutor data here, and the tutor data is going to be written into an cloud storage bucket. Okay, so and from the cloud storage bucket we are going to ingest the data into Snowflake. So let's see how this happens in our architecture. So we have a listener here. So what the listener does is listens for each and every event in Twitter. Like if you give a hashtag kind of like COVID-19 or some like India or some hashtags, we have a listener that will listen for the Twitter stream data, and we will be writing the stream data to any cloud platform, whether it can be a Google Cloud or Azure or AWS, it doesn't matter. So you will be writing it to any cloud storage, and once the data is returned to a cloud storage, we need to ingest the data into Snowflake, right? And there are a couple of ways to do that, and in this demo we're going to choose how to do it in a real-time way. It will be like not there will be a couple of latencies, but that's fine. We can achieve it using a couple of in a couple of minutes actually. So basically, what you're doing is we are writing the data to a storage bucket, and from the storage bucket, we are loading the data into Snowflake using Snowpipe. Snowpipe, you can consider it as a virtual warehouse that runs only when you know there is an event happen, right? So you don't need to run the event every time. Like you don't need to see, for example, the event might occur only at around a particular time, like around 12 to 3 alone. You will be getting the data. You don't need to create a dedicated warehouse to write the data for it, right? So you're creating a snow pipe, and the snow pipe will triggered only when you have a new event. Okay, so from the new event we will be writing the data to a Twitter table in the Snowflake database, and we are creating a Twitter view, so that the Twitter table is a kind of a raw data. It When from the raw data we are just writing it to an create structured format of a Twitter view, and from the Twitter view we can use a Power BI and kind of a connector. Okay, so before getting into what is Snowflake, you can go into Snowflake page, right? And you can just sign up for a Snowflake account, and once you sign up, and you can just choose the platform, that is the cloud platform that you want, whether it's a Google Cloud or Azure or AWS, and you will be given a specific ID, and using that ID and username and password, you can just log into your Snowflake account. Okay, so this is, I signed up for an account, and this is my ID. Okay. Sorry guys, my laptop is being screwed. I'm not sure why it's so slow. Yeah. So I'm logging to Snowflake. So edit login. Okay, so once you're logged in, you have this is the screen that you're gonna get, right? And so you can see like you
Prashant,
have
could you please increase your browser size?
browser size.
Yeah,
You want me to increase your check?
yeah, the 100% to 125 or 125% or so.
Is it fine now?
Yes, much better. Yeah.
Yeah. So like you can see the here, right? You have databases, and you have warehouses and data marketplace, all those stuff. So these are all the functionality that is being provided by Snowflake. So if you go to databases here, you can see that the available databases for this particular account, right? So you can see the databases. You can create a database here, right? You can create a database here, and then do all those stuff. And same way, you can have warehouses here, right? So what is a warehouse? Warehouse is kind of a virtual machine that runs, that queries your data, right? And it has a kind of it auto scales itself, right? You can it auto scales on the data that you have, and you can create multiple warehouses, and you can also like you can configure it to auto scale the warehouse, right? See, for example, you can go to create a warehouse. Yeah, so you can create a warehouse here, and you can select the size here. The size is going to be like kind of, it's actually a simple metric. They're what they are following is like kind of an X, small, medium, large, and the bigger the size, you're going to get a bigger machine. That's it, right? And for it's like for 1 hour of usage, they're gonna charge you like one credit, and one credit is like around $3. Like, so in simple math, it's like for 1 hour usage of X small machine, you're gonna pay $3 to Snowflake, right? And the advantage of using Snowflake here is like you can set the minimum and maximum cluster. Let's say, like for example, your basic workload is going to be around 9 to 6, right? So after 6, you might not even get so much of query load or performance. You don't need that kind of uh, uh, query load to your backend systems, right? So at that time, what we can do is you can configure an automatic clustering. So what it does is like you can set a minimum and max cluster, and based upon your query load, the warehouse scales automatically. So you will be paying only when you have when there is a need for when the QPS is high. You don't need to pay for a large volume machine at all the time, right? So that's one of the biggest advantage of using Snowflake warehouses. And then okay, let's get into the demo. Okay, so you have something called a worksheets here. So worksheet is kind of you can consider it as an SQL terminal where you can run your SQL commands. Okay, okay. Before getting into this demo, I will also show what is a role. Yeah. So you have a couple of roles here, right? You can see account admin, public, security admin, sysadmin, and user admin, right? So account admin is kind of like he's the god owner of this account. Like he can do any aspect whatever he wants. And public is kind of the least minimum account role that you can give. And security admin will have access to the security aspects, like he can configure like the IP whitelisting and similar kind of aspects. And sysadmin is kind of a who can create warehouses, manage databases, and then manage users as well. And user admin is kind of a specific to create and manage users as well, right? So what we are doing is here, if you go and check out in the worksheet, we are using a role as sysadmin, right? So sysadmin can create warehouses. Okay, so we are using the role as sysadmin, right? And then we're going to create a warehouse called Twitter ingestion. Okay, so creating a warehouse is as simple as that. You can just you have to run a query so that the warehouse will get automatically created. So the query is simple here, right? So you can see here, create a replace warehouse, and the warehouse name I'm naming it as Twitter ingestion, and the warehouse size I'm going to make it as x small, and the auto suspend is going to be like after 300 seconds there is no usage, the warehouse will automatically shut down. So you do, and it will automatically resume when you have a first query, right? And the first query alone takes around the system up in around 1.5 milliseconds as well, right? And the initial load query alone will have a little bit of latency, but that's fine, right? And you're creating another database to store the Twitter feature, right? So I'm creating a database here. Right. So the database has been created. Like if you go and refresh on the site, yeah, you can see the database here. Right? And now what we are going to do is we are going to create a stage. A stage is nothing but a kind of a data loading platform for Snowflake. Snowflake, we're going to map it to an S3 bucket here. Like this is going to be in our case we are going to use S3 as our stage, and so Twitter bucket demo is the bucket name of which you're going to database that we're going to use, and the credentials are the AWS credentials that we're going to use, right? So if you go here and let me show me AWS screen. Right, we have a bucket here, Twitter bucket demo, right? And there's no records here, right? So we haven't put the records here. So we have created Twitter data here. Okay. So what we are doing is we are creating a stage. Stage is uh, kind of a platform to load the data from your S3 bucket into the Snowflake platform. Okay. So I'm creating a stage for this particular bucket, Twitter bucket demo, right? So we have created a stage, and we just want to change what are the stages that are available here, right? So you can check using you can have multiple databases, and you can have multiple multiple stages as well, right? So you can see here, like you can check like what are the in what region it was created. You can configure what region the stage need to be, right? And that's it. Yeah. So you are creating another table that is kind of a raw table, right, to store the data, right? So variant is kind of a format that accepts both uh, JSON array as well as a JSON object. Okay. So if you are not sure whether the data is going to be an array or object, you can just go with a variant format, so that you will not get any errors when you write the data. So we are creating a variant data type here. Yeah. So what we are doing is like we are creating a pipe, right? Like I said, we need to load the data when we get an the data is pushed into the S3 bucket, right? So we need to load the data at when we get the data. So what we are doing is we are trying to create a pipe here, snow pipe, and the snow pipe will automatically listen to the event changes that the data has happened, right? So what we are doing is like we are creating a snow pipe here. Yeah. So a snow pipe has been created, right? So if you go and check the snow pipes, you can look at the attributes here of a snow pipe, right? So what is the definition that says here is that see, it's the definition is like you're copying the data from the public tweets, right? So the Twitter.public tweets is the database that we have created, right? And that what we are doing is like we are loading the data from TwitterDB.public tweets is the stage that you have created, and the file format is the JSON format. And Snowflake supports JSON, CSV, or Avro and Parquet, all those files formats. Look, we are now for this demo we are choosing JSON, and what we are doing is like we are loading the data from the S3 and we are copying it into a TwitterDB table. Okay, so that is what the Snowpipe does. This is you can consider this kind of a job what the Snowpipe does. Okay, and you have kind of a notification channel. What is this notification channel is it's kind of you want to notify Snowpipe that you have the data has been updated in S3, right? So we and Snowflake needs to know that this data has been updated. So Snowflake provides us kind of an ARN SQS listener queue, and what we need to do is we need to copy this, we need to update this listener queue into S3, right? So let's go to S3. So this is the database that we have, and what I mean here is like this is kind of event notification, right? So whatever event, like if there is an S3 event happening, if you put a data to S3 and if you know create a bucket or create any other thing, you can configure events, and those using those events you can trigger n number of actions. And this is kind of a cloud agnostic feature that has been provided in all the most of the cloud platforms, in even in cloud Google Cloud Storage, or even Azure has the same functionality, and you can use the same methods to in Google Cloud as well, or Azure as well. Okay, so you can go to properties here, and if you check something here like kind of a event ingestion, right? So what is like, okay, I think this has been already created. Okay, let me do one thing. I will edit it. Okay, yeah. So if you look into here, like the event name that I have given is like auto ingest Snowflake, and what I'm listening for is, yeah, what I'm listening for is like what all I'm listening just for the create events of the S3. So whatever, like if there is a new record that has been inserted, the event will be triggered and will be notified to a Snowpipe, and Snowpipe will ingest the data into S3. Okay, so we need to change the SNS queue to here. Like, so this is our SQS queue here. Okay, so basically like you can in S3 you can configure what you need to do when an event happens, right? So Snowflake uses SQS queue to for notifications. So we are creating an SQS queue, and this is SQS queue ARN, right? And we are giving the SQS queue here and here. Yeah. Okay. Right. So we have done for configuring like S3, and now the system is up for listening the S3 changes, right? Let's get into the code. So this is kind of a basic code that what I have done is like I'm listening to, I've created a Twitter key and a secret key, all those details, right? And what we're doing is right when we are using the tweet key, I'm listening for an event, like in this example, I'm listening for COVID-19 event, right? And I'm just gonna create a listener, and that listener is gonna write those files to S3. Okay, so I'm not getting deep into the code. I will pushing it to code a GitHub or a thing like. So what we are doing is like we are pushing the format to an S3 bucket, right? And in the S3 bucket, using Bota library, we are pushing it, and the format would be in hours, right? So this is the basic of what the code does. I'm just running the script. Okay. So like you say, we are listening to the COVID-19 hashtag. The event loop just takes a thread back. Just give us a minute. Yeah, so the data has been uploaded to S3. So you can just go and check here. Okay, let me refresh the screen. Yeah, so you can see like a bucket has been created, right? And you have the data based upon the year and the month and all those stuff. Okay, so I will go to sorry, I will go to this tab, right? So we have done with the part one of the demo. Now we will go to the part two. So now we have the data here, right? So what we have done is we created an warehouse, right? So what I'm doing is like I'm gonna uh, log in as so I'm already as a sysadmin. Okay, and then I'm gonna use Twitter ingestion warehouse, and then I'm gonna use the schema of public. Like so, if you check the database here, we have a schema here. So I'm just gonna select what schema that I need to use, and you can just have a look at the list of tweets that have been ingested. See, so these are the list of tweets that have been ingested right now, and you can check. This is kind of an sample tweet that has been written, right? So this is the data from Snowflake, sorry, from Twitter that has been ingested into Snowflake, right? And then you can check the status of the snow pipe, right? So you want to know whether the snow pipe is running, whether there is an event happened, whether the data has been ingestion happening or not. You can just run here. So you can check that the execution status has been running, right? So the data has been ingesting into our system, right? And you can check the number of records that have been ingested from Snowflake as well, into Snowflake, right? And, so you can check like around 400 records has been inserted, and what we are doing is right. If you check the row here, if you check the data here, right? See, like we created a row, and then we created another a JSON variant, right? The tweet is going to be JSON variant. We're just saving the data in a raw format. We aren't doing any processing over it, right? But the same data cannot be used as an for the users, right? For the BI users, we can't use it as a BI tool without any transformation, right? So we need a kind of a transformation here. So what we're doing is right. We are transforming this data as a view, and kind of a table structured format that can be used and connected with a BI tool and do some queries, right? So this is kind of a simple SQL query, right? If you look at this query, yeah. So we are creating a view, right? And what we're doing is like uh, select tweet of keyword, and we are casting it as a string. And tweet is the JSON payload that we have. That is the JSON raw data. And what we are doing is we are taking the keyword, that is the keyword is the key here, and casting it as a string. And the same way, what we are doing is like there is a created add field here, right? So we are casting it as a timestamp, right? So the same way we can use typecast and create a view for that data type, so that you can dynamically change the JSON values to a view. Right? So I'm going to run this command and create a view. Yeah. So now if you look at it, right? Yeah. See, now the JSON data has been formatted into a no organized tradition in a relational way, right? So you can run queries over it as well, right? So you can do any queries, like you can do any actions or it's kind of more of an queryable data, right? So we have created a view now, like to expose this to an external user, like kind of a BA user, right? So we need to, what we can do is like, we have done all these things using our SQL queries, right? So the same things can be done via Snowflake console as well, right? So now I'm going to show you how to do it via our console. So you can go to warehouses directly here, right? So what we have done is like have created a warehouse for ingesting the data, right? The same way I can create another warehouse to, so that I can expose the data warehouse to users so that they can use run BA queries over it. So the main difference here is like for Twitter ingestion, right? I can create a values of around medium size or something like production system, and for running BI, right? So BI might take around depending upon the complexity, right? So I can create a BI warehouse that has a larger capacity, right? I can go with double Excel and minimum start size of around 4 or 5 clusters, right? So depending upon the need, I can create a warehouse. Okay, so what I'm going to use like for this step, for using users, I'm going to create BI reporting. Okay, so it's going to be BI underscore reporting. I'm going to create a warehouse. I'm going to create a small warehouse, right? The maximum clusters, that is the maximum clusters like going to be 2, and the minimum is going to be 1, right? So this is basically the performance is based upon your queries. So if you're having large number of queries, the cluster size will automatically grow. So it's kind of automatic scaling, and you'll be paying only when your clusters are high loads, right? So you don't need to pay for you don't need to create a dedicated cluster and pay for upfront whether you're using it or not, right? And you have a scaling policy here, like you can be standard or economy. Standard is kind of it's an algorithm that will spin up the clusters immediately, and economy is based upon your active clusters. The cluster spinner could be little bit conservative actually. Okay, so the auto suspend is going to be like if there is no 10 minutes of auto news, and the system will be being shut down, right? And you can go and see the SQL query of what we have created, and you can even copy this query and run it in a worksheet so that the variables can be created in that way also, right? So for this demo purpose, I'm creating it here. Okay. So we have created a reporting warehouse, and now let it be up. So like I previously mentioned, we have Snowflake roles, right? So we need to create a role here, right, for BA user. I'm creating a role for BA user. Okay. I'm giving him the least permission, right, to log in as a public, right? Okay. So I'm just creating a role. Yeah. So the role has been applied here, right? So I'll go to head into users as well. I create an user. See, I'm creating a new user here. He gonna access. I'm just going to create a password. I'm just gonna leave option the password. So these are I'm just leaving it blank. And the default virus that I'm gonna give is BA reporting. And the default role is gonna be BA role. So I created a role. I'm assigning the role to this particular user. Okay. Okay. So the advantage with Snowflake is like the permissions are at the granular level. You need to provide access for this user for each and everything. So, for example, if you consider this BA user don't need to access the warehouses of compute or Twitter ingestion, uh, they won't be able to access it until you provide it, right? So it's kind of an access specific. So now you need to go to this particular warehouse and then provide access to him, right? So you need to provide access to this. Okay. So if you go to grant privileges, and I'm providing access to usage access. Usage is there are a couple of grants here: modify, monitor, operate. All these are like kind of create and monitor, and operate is kind of you can change the roles as well. So I'm just gonna give him usage alone so that he can use it And then what is the role I'm going to give this like kind of a BA role. So I've given access BA role to access for this BA reporting warehouse. Now I need to provide him access to the database as well. Okay. So let me head into database as well. What I'm doing this here, Twitter DBA, right? I'm providing access to the BA role. So I'm just giving him the usage the same way, right? He won't be able to do any other thing, just run the SQL queries. So the things is like all these are like in the granular level. So it's like you need to go and give it at the table level as well. I'm going to give access to the tables as well, and there are ways you can do it with in a single query also. I'm just trying to show how to do it using a console. So here, I'm giving here access to let me give access to the schema as well. Okay. Yeah. So we have a schema here, right? So public, we need to give him access to the schema as well. So I'm giving him public. Okay. So I'm giving the same way. I'm giving him the usage grant and to the BA. So once it's created, we have created a view, right? If you check, we have created a view. So I'm creating an access to this, providing access to this view so that he will be able to see only that no formatted table. We use a kind of a virtual table, right? So you'll be only able to see the formatted table. Right? So I'm just giving him the view access. So you can go do kind of a select queries on this view to this particular feature. Yeah. So also you can look into the pipes that you have created here. Like what are the pipes that you have created? Like what is the URL? You can have it. You can check it here as well, right? So yeah. So I think Dinesh can check over with Power BI to with the queries. Right? Dinesh, can you check whether you are able to log in with that user and
Yeah. Can I share my screen, Prashant, or
yeah, yeah, sure. You can take over. Yeah.
okay,
Uh,
okay, I'll take over the screen. So, guys, I think you're able to follow what Prashant has shared. Uh, from the data generation portion, which is nothing but the Twitter, he has created a pipeline to ingest the data into Snowflake. And now what I'm going to do is from Snowflake, I'm going to connect it with the BI tool, that is a business intelligence tool, Power BI, to analyze that, right? So before that, let me log in with the respective user, BI underscore user, and the password is I think it should be right. Yeah. In the same tenant, as Snowflake is a managed, fully managed service, I didn't do anything. I just logged into this particular portal, the same portal which Prashant has created. I logged into this particular portal as be a user. Okay. So if you see here, I'm able to see the digital databases. Ignore these three. I'm able to see Twitter database. Once I click that, I'm able to see. I don't able to see any tables at all here because Prashant hasn't assigned any table for this particular user. But I should be able to see the view. As you see here, I'm able to see the view here, right? And similarly, let me create a worksheet and let me just try to play with something. So I'm able to see the view, but okay, let me just try to delete that view. So as expected, I get this error, right? So tweets BI does not exist or not authorized, which is nothing but as my login BI underscore user login, I'll not be able to delete or insert any tables uh, uh, from this particular account. Whereas I'll be able to query the data. Okay, I think it should work. Okay, I didn't selected the database. That's what the problem is. So I'll be able. I can select the database from here, or I can specify it in the SQL query as well. Now it should be working. So as you see here, I was able to select the data, but I'll not be able to perform any. Uh, I'll not be able to tamper the data by deleting it or inserting another. So the error shows clearly that insufficient privileges to operate on this particular view, right? So by the same way, let me connect the data, Snowflake data in this Power BI. So in the Power BI, in get data option, I'm going to, yeah, select Snowflake, and in the server part, I'm going to give you the same server information, that is the account name, and warehouse. I'm going to give it as BA underscore WH. Is that right, Prashant? So this is a full
Yeah,
account. So I'm BA underscore reporting. Oh, I'm sorry.
yeah,
BA underscore reporting, and role name is nothing but
B underscore.
okay, BA underscore role. So I'm just I have just clicked OK, and it will check the credentials. Okay, so now it will check the account name and all those things, and it will ask for the username and password. Now it's going to be BA underscore user and the password. I think it is taking some time because the dedicated warehouse was created for this particular scenario, right? BAE scenario. So that particular warehouse will be spinning up, fetching, accepting the query, and it will be executing, and it will be giving back the result. Even we'll be able to see the progress here as well. Warehouses, this BI and reporting. Okay, I don't have any privilege. Let me switch back to the other account. So as you could see, we were able to see the load that has happened right now, and the data ingestion also has started. Actually, it will be importing all the rows from Snowflake into this particular mission. So the performance depends on both the mission and the Snowflake as well. So in this navigation, I will be able to see the metadata, that is the account name and the list of databases and the schema and within that schema, what are the tables and views I'm able to access. So when it is view, the icon will be something different like this with two rectangles. When it is table, it will be something like one table alone. Sorry, one window like this. It will be when it is view, it will be like this with two window. Okay. So let me just give load. Now it will completely retrieve all the data from Snowflake into Power BI. So meanwhile, let us check how the query execution is happening. We can always go and check the usage from this account. And BI underscore reporting is my what to say, the warehouse name, and I'm able to see the consumption. 1.20 credits has been used by this particular warehouse. So I'm able to see the drill down portion also, 1.2%, how much percent I have used. Out of 100%, this particular warehouse has used the most. Even I can click and see in detail how the data fetch has happened and what is the usage level. So for compute, it has compute 0.08 credits, similarly 0.33 credits. So while it has been used day to day, then obviously this kind of monitoring is very essential to check out. So meanwhile, our data has been imported, and let us check how the data is being showed in Power BI. So this is the data. I'm able to see the keyword, creator at text. So actually, the data has been fetched as JSON, that is semi-structured type, but we are able to play with that same data in a row column-wise format without any data copying. The table still exists in Power BI. The table still exists in Power BI, and we are able to access that JSON data as a kind of view, virtual view, without any data copying at all, right? So with this data, I'm all alone. I'll be able to play as many filters possible. If I have one more set of table like Twitter's data along with the sentiment analysis data and all those things, then I will be able to do all the analysis as my wish. So I could have, I can choose as many columns and create the widgets by selecting different metrics and dimensions, and this is all about. So one more thing is we'll be able to, Prashant has already told, and even this is the preview UI of Snowflake. What Prashant has showed is the actual traditional UI. Snowflake also has a preview UI. In this, the way of understanding will be better than the traditional UI. For example, if you could see the role, you could see clearly that account admin, what are all permissions he has. Similarly, when it comes to BI role, it is all about public, right? On top of public, and a BI role has been created. But when it comes to sysadmin, uh, based on account admin, this sysadmin has been created. So such a kind of things also there in Snowflake. You can play as you like. And with that, let me jump into the questions we have. So is Snowflake available as managed service in cloud? Yes, definitely. Snowflake is available as managed service only in cloud. It is not available as an installable software where you can install it in your own machine or in a data center and all those things. It is purely 100% available only in cloud, that too only as a managed service. And there is another question. What is couldn't understand what is column format and row format. I just picked the image to make it understandable quickly. So row format is nothing but like this. The OLTP databases like SQL Server or PostgreSQL, it will be storing the data in this format where you'll be having the columns like last name, first name, email, and the data will be stored in row wise. User one, last name, first name, email. User two, last name, first name, email. Like this, it will be stored in row wise. In OLAP, since it is dedicated only for analytics, the format will be changed and it will be stored as column format. So last name means all those columns will be there. Sorry, data will be there. First name means all those data. The reason is because in while analyzing, all the columns will not be fetched, right? Only specific set of columns will be fetched. So in that case, only accessing specific columns will be enough. Not all the rows or all the columns will be fetched. Like this, they have architected the columnar storage. And we have another question like, what is cubes? So cubes are nothing but you'll be having data in SQL Server or PostgreSQL, whatever it may be. On top of that, you'll be creating a cube like this. You'll be like what to say? You'll be creating a cube with a dimension column. Based on that dimension column, the aggregations will be automatically configured, and while querying, the data fetching will be very quicker. For example, this is nothing but this particular cube line is sales amount, and this particular cube line is diesel, and this particular cube line is months, right? So the totally three dimensions are there. Within each of this cube, aggregation columns values will be stored. For example, if you want sales amount of diesel product in January month alone, directly the query will hit this cube and directly access this particular cube alone. It will not once again fetch all the data and compute it and provide the result, right? You understand the advantage of creating cube, right? So before OLAP, I mean, sorry, before data warehouses came, the such kind of cubes have been created on top of OLTP databases, and the analytics was being run upon. Okay, so we have another question. Prashant, can you take this?
Yeah, sure. You recommend that? So basically, like I agree. I understand. Like you're asking to use Snowflake as a traditional OLTP database, right? So we can use it, but we would recommend not because of the kind of data that has been stored, right? See, Snowflake has been storing the data in partitions. So we need to ingest the data to Snowflake. If we are writing a couple of writes to the Snowflake database, we need to write it in a batches, like around 15 or 20 minutes delay, right? So using that, we need to write it in batches because of uh, uh, the like the partition will not be repartitioned each and every time again. So using it as a node OLTP database isn't recommended. You can use it as a traditional data warehouse actually, but using it as an OLTP, you will be the database is built for OLTP transactions. See, basically, like the major difference between OLTP and OLAP is for analytical, and OLTP is for transaction. If you want your transaction to be faster, right, and if you're going to use only the update and then get, right, then you should go with OLTP. And if you're going to do some kind of queries over it, and then like kind of reporting queries, then you should go with OLAP databases.
Okay, I think we don't have any other question. So with that, if there is no question, we can sign off for the day. And I request you to post your feedbacks as comments, or if you need any specific topic to be conducted as session, please specify in the comment section of this events page in meetup.com, so that we'll be able to plan accordingly. So with that, I thank all the attendees for taking your time to attend the session. And yeah, that's it. Prashant, do you want to say anything?
Yeah, yeah. Thank you, guys. Thank you, guys.
Okay, fine. Okay, thank you.